Complex number. Complex numbers are a fundamental concept in mathematics that extends the realm of real numbers and plays a crucial role in various branches of science and engineering. A complex number is a number of the form plus by, where a and b are real numbers and I represents the imaginary unit, defined as the square root of -1. In this essay, we will explore the properties, operations, applications, and significance of complex numbers. Properties of complex numbers. Real and imaginary parts. In a complex number, the real part is represented by a and the imaginary part by b. The real part indicates the position on the real number line, while the imaginary part represents the position on the imaginary number line. Conjugate. The conjugate of a complex number a plus by is denoted as a by. It involves changing the sign of the imaginary part while leaving the real part unchanged. Modulus. The modulus or absolute value of a complex number a plus by is denoted as a plus by and is calculated as the square root of the sum of the squares of the real and imaginary parts, a plus b. The modulus represents the distance from the origin to the complex number plotted in the complex plane. Argument. The argument or phase of a complex number is denoted as argz and represents the angle between the positive real axis and the line connecting the origin to the complex number in the complex plane. The argument can be expressed in radians or degrees. Operations with complex numbers. Addition. To add two complex numbers, simply add their real parts and imaginary parts separately. For example, a plus by plus c plus d equals a plus c plus b plus di. Subtraction. Similar to addition, subtraction of complex numbers involves subtracting their real and imaginary parts separately. For example, a plus by c plus d equals a c plus b di. Multiplication. To complex numbers, multiply the numerator and denominator by the conjugate of the denominator and simplify. For example, a plus by c plus d equals a plus by c d c plus dcd. Applications of complex numbers. Engineering and physics. Complex numbers are extensively used in electrical engineering, particularly in the analysis of AC circuits and signals. They enable the representation of sinusoidal quantities such as voltage and current using phasors. Additionally, complex numbers find applications in areas like control systems, signal processing, quantum mechanics, and fluid dynamics. Mathematics. Complex analysis is a branch of mathematics that deals with functions of complex numbers. It explores topics like analytic functions, contour integration, and the theory of residues. Complex analysis has numerous applications in other branches of mathematics, such as number theory, differential equations, and calculus. Computer science. Complex numbers are employed in various fields of computer science, such as computer graphics, image processing, cryptography, and signal analysis. They facilitate the manipulation and representation of mathematical entities and algorithms in these domains. Fractal geometry. Fractals, which are complex, self-repeating geometric patterns, rely heavily on complex numbers. The simple definition of complex number is that any number that can be written in the form of a plus ib, where a represents the real part and I represents the imaginary part. Thanks for watching.